Pluto is a remote and enigmatic planet that was once considered part of our solar system's planetary lineup. However, after some surprising revelations by prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku, Pluto has returned to the spotlight with an astonishing claim. They suggest that Pluto is on a potential collision course with Neptune. But how could this be possible? What might the consequences be if such a colossal event were to occur? Are we witnessing an intriguing cosmic anomaly? Or is there something more to this impending astronomical clash? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, once classified as a planet before being reclassified as a dwarf planet due to its unusual orbit, continues to captivate astronomers and space enthusiasts alike. Recent studies by leading scientists have highlighted a concerning proximity between Pluto's orbit and Neptune's, with both Tyson and Kaku raising alarms about the potential for a dangerous collision that could pose a significant threat to Earth. So, how could such an event even happen? Pluto's orbit around the Sun is unlike any other planet in our solar system. It takes a staggering 248 years to complete a single orbit, and since its discovery in 1930, it has not yet finished one full revolution. What makes Pluto's orbit even more intriguing is its highly elliptical shape, which contrasts with the almost circular orbits of the major planets. Additionally, Pluto's orbit is tilted at a steep angle of 17 degrees to the plane of the ecliptic, adding complexity to its path. This unique orbital pattern results in some fascinating interactions between Pluto's and Neptune's orbits. For about 20 years during each orbit, Pluto actually comes closer to the Sun than Neptune. This raises the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influence of other planets. Astronomers first began analyzing Pluto's unusual orbit after its discovery, as its tilted and elongated path set it apart from the other planets. Early predictions about its orbital mechanics revealed that Pluto's path does indeed cross Neptune's, which seemed to suggest a potential collision. However, these concerns were alleviated by the understanding that the gravitational interactions between Pluto, Neptune, and the Sun work in a delicate balance that prevents such a collision. The key to this stability lies in a phenomenon known as the three-body problem in celestial mechanics. This problem involves calculating the movements of three objects, such as Pluto, Neptune, and the Sun, which influence each other's orbits through gravity. It's akin to trying to predict the future positions of these objects based on their current trajectories. In Pluto's case, the complex interplay of gravitational forces from Neptune and the Sun prevents a collision. Two important concepts, libration and resonance, help explain why Pluto's orbit remains stable despite its unusual shape. Libration refers to the way Pluto's orbit is aligned relative to Neptune's, ensuring that when Pluto crosses Neptune's orbit, it does so at least 90 degrees away from Neptune. This separation is crucial in preventing a collision. Resonance, on the other hand, describes the synchronized movement of celestial bodies within their orbits. For Pluto, this means that it's always aligned in a way that keeps it safely away from Neptune at crucial points in their respective orbits. Additionally, another concept called quasi-resonance further stabilizes Pluto's orbit. This principle, developed by scientists such as Yoshio Kozai and others, explains how the gravitational interactions between Pluto, Neptune, and the Sun help maintain the stability of Pluto's orbit despite its eccentricities. This stability is further illustrated by the long-term predictability of Pluto's orbit. Despite its seemingly erratic path, Pluto's orbit remains stable over billions of years, thanks to the intricate gravitational relationships that govern its movement around the Sun. However, predicting celestial events, especially those involving irregular orbits like Pluto's, presents significant challenges. The inherent unpredictability of these systems means that long-term forecasts are often fraught with uncertainties. While mathematical models provide a useful tool for understanding and predicting the behavior of celestial bodies, they also highlight the limitations of our predictive abilities. Small errors in initial conditions or unforeseen gravitational influences can lead to vastly different outcomes, making precise predictions difficult. The erratic nature of celestial orbits, like Pluto's, reminds us of the constantly evolving and dynamic nature of the universe. Although we've made significant strides in understanding space, the case of Pluto serves as a reminder that our knowledge of the cosmos is still limited, and the mysteries of the universe continue to unfold. The gravitational influence of the giant planets on Pluto's orbit provides valuable insights into the broader dynamics of our solar system. It reveals how the presence and positioning of each planet can significantly affect the stability and behavior of other bodies within the system. Despite these complex forces working to prevent such an event, why are prominent astrophysicists recently raising concerns about a potential collision between Pluto and Neptune? Neil deGrasse Tyson, a leading astrophysicist and a key figure in promoting cosmology, offers an intriguing perspective on the mysteries of our nearby solar system, particularly the fascinating case of Pluto. Tyson, known for his role in the reclassification of Pluto from a planet to a dwarf planet, provides thoughtful commentary on the evolving nature of celestial mechanics and the public's growing interest in the unknown realms of space. He views the reclassification not as a demotion but as a significant shift aligned with our advancing understanding of the many bodies orbiting the Sun. Tyson's approach to cosmic mechanics is rooted in continuous learning and evolution, acknowledging that the complexities of orbits like Pluto's are indicative of the vast discoveries still to be made in space. The ongoing interest in questions like the potential interactions between Pluto and Neptune highlights the dynamic and unpredictable nature of our nearby solar system. His work underscores that as we uncover more about space, we generate more questions, prompting us to delve deeper and refine our understanding of the universe. Michio Kaku, another respected physicist and futurist, offers a different yet complementary viewpoint on the mysteries of space, focusing on the often chaotic forces that shape our universe. Kaku is known for his ability to connect complex scientific ideas with visionary concepts, making him a significant voice in discussions on cosmic mechanics and their broader implications for humanity. His perspective on Pluto and its orbit emphasizes the need for ongoing observation and advanced modeling to predict and comprehend potential major events. Kaku views the interactions between celestial bodies as an important area of study, not only for academic interest but also for practical considerations. The potential impact between Pluto and Neptune, for example, is not merely a theoretical scenario but a reflection of the dynamic and sometimes violent nature of space. Kaku's futuristic viewpoint encourages us to consider the broader consequences of such events, from their effect on our understanding of the solar system to the potential need for future space interventions. His perspective stresses the importance of being prepared for the unexpected in space. Kaku proposes that the more we understand the forces at play, the better equipped we will be to navigate and potentially mitigate the effects of major events. Both Tyson and Kaku emphasize that space is a domain of boundless discovery, and our current understanding, while significant, remains limited. Their focus on the need for continuous investigation and advanced modeling reflects the evolving nature of space science. They highlight the importance of not only understanding celestial mechanics as they are now but also predicting how they might change in the future. The potential impact scenario between Pluto and Neptune serves as a case study for the broader challenges and opportunities in space exploration. It underscores the need for effective scientific inquiry, cutting-edge technology, and a willingness to revise our understanding as new data emerges. For Tyson and Kaku, the mysteries of space, exemplified by Pluto's orbit, represent an exciting call to action for the scientific community and humanity to continue pushing the boundaries of knowledge. There is a broad scientific consensus that, for the foreseeable future, the orbits of Pluto and Neptune will remain stable due to their mutual orbital resonance and the various gravitational forces acting on them. As a result, a direct collision between Pluto and Neptune is highly unlikely. However, the complexities and potential disturbances in their orbital dynamics suggest that astronomers should continue to monitor and study these celestial bodies to gain a better understanding of their long-term behavior and any potential risks they may pose. While the chance of a Pluto-Neptune impact is largely theoretical and considered improbable with current knowledge, it highlights the importance of ongoing observation and research in space science. Advances in technology, including improved telescopes and computational models, will help astronomers refine their simulations and predictions, ensuring that we stay ahead of the dynamic and ever-changing nature of our nearby solar system. Tyson's viewpoint on Pluto's reclassification, along with Kaku's emphasis on the unpredictable nature of celestial mechanics, Both stress the need for ongoing research and a flexible understanding of our universe. The potential impact scenario, while highlighting the dynamic and intricate interactions within our nearby solar system, ultimately serves as a reminder of the vast and still mysterious aspects of space. Through continued exploration and observation, we strive to unravel these mysteries, ensuring that our knowledge remains in sync with the constantly evolving universe. Pluto continues to captivate scientists and space enthusiasts alike with its distant, enigmatic nature. Although its status as a dwarf planet has long been debated, its orbit and unique characteristics continue to engage researchers. Recent developments have once again placed Pluto at the center of attention, with the possibility of a gravitational connection between Pluto and Neptune becoming a focal point for the space community. With Tyson and Kaku bringing this issue to the forefront, the discussion surrounding Pluto and its orbit is far from over. The potential influence of Pluto and Neptune continues to spark further interest and exploration. Studying these distant celestial bodies promises to offer valuable insights into the mechanics of our solar system. As we explore deeper into space, the dynamic and unpredictable nature of our cosmic neighborhood highlights the need for continuous vigilance and research. The potential link between Pluto and Neptune remains a topic of scientific curiosity, but it is essential to consider the broader context of space exploration and the methods used to study objects like Pluto. The discovery of potential threats, such as a possible Pluto-Neptune collision, serves as a reminder of the complexity and unpredictability inherent in the universe. It underscores the intricate forces at play within our solar system, where even the most stable orbits might harbor hidden vulnerabilities. One of the primary tools used in such studies is computational modeling, which allows scientists to predict and simulate the behavior of planets and dwarf planets over long timescales by incorporating known variables such as mass, speed, and distance. These simulations help project future movements and assess the stability of orbits like Pluto's. This technique relies on powerful computers and advanced algorithms to process vast amounts of data and complex calculations. This method is especially crucial when examining objects with irregular orbits, like Pluto, whose path around the Sun is distinctly different from that of the other planets in our solar system. Gravitational interactions between celestial bodies play a significant role, as Pluto's orbit crosses Neptune's. Hypothetically, the gravitational pull between these two bodies could lead to unpredictable outcomes over long periods. However, due to the resonance between Pluto and Neptune, their orbits remain in a stable relationship. This gravitational resonance ensures that, even when Pluto approaches Neptune's orbit, a collision is prevented. The underlying physics of this resonance is fascinating, as it illustrates how subtle gravitational forces can synchronize the movements of two distant bodies, preventing catastrophic events like a collision. That said, many questions still remain about how other factors in the solar system might influence Pluto's orbit. For example, the gravitational influence of planets like Jupiter, Saturn, and Uranus could potentially disrupt the delicate balance that keeps Pluto and Neptune in stable orbits. These giant planets exert their own gravitational forces, which could cause minor changes in Pluto's trajectory. While these changes are typically small over millions or billions of years, they could accumulate and lead to more significant alterations. This is why astronomers continue to monitor Pluto's orbit closely for any signs of deviation that could suggest a future disruption. Beyond gravitational forces, the Sun's own influence plays a crucial role in shaping the orbits of objects in the outer solar system. While the Sun's gravity governs the movement of all objects within the solar system, including planets and dwarf planets like Pluto, its gravitational pull on Pluto is weaker due to the planet's distance from the Sun. As a result, Pluto's orbit is more susceptible to external influences, such as variations in the Sun's energy output over time, which could impact the behavior of objects in the Kuiper belt, where Pluto resides. These subtle changes could potentially affect the long-term stability of Pluto's orbit. Another important factor in studying Pluto is its environment. Pluto resides in the Kuiper belt, a region of space populated by countless small icy bodies and dwarf planets. The Kuiper belt remains largely unexplored, with many of its objects still poorly understood. However, as astronomers gather more data from space missions like NASA's New Horizons, which conducted a flyby of Pluto in 2015, We are beginning to gain insights into this remote region. New Horizons provided stunning close-up images of Pluto and its moons, revealing a complex world of icy mountains, vast plains, and unusual atmospheric features. This data has raised new questions about the formation and evolution of the outer solar system, as well as how objects like Pluto interact with their surroundings. As scientists continue to refine our understanding of Pluto and its relationship with Neptune, it is important to recognize the broader implications for space exploration and the potential for future discoveries. Studying distant objects like Pluto helps us learn more about the history of the solar system and the forces that shape planetary bodies. Additionally, these discoveries contribute to our ability to predict the future movements of celestial objects, which could have practical applications for space missions and the future of human space exploration. With ongoing advancements in technology, our ability to observe and study the outer reaches of the solar system is expanding, opening new frontiers for all of humanity. While the likelihood of a Pluto-Neptune collision is extremely low, the fact that such a scenario has captured the imagination of both scientists and the public underscores the continuing fascination with the mysteries of space. The complexity of Pluto's orbit, the forces that shape it, and its interactions with other objects in the solar system all remind us of the vastness and unpredictability of the universe. As we continue to observe and study these celestial bodies, our understanding of the solar system will grow, uncovering new insights and raising new questions. The case of Pluto and Neptune is just one example of the wonders of space that continue to captivate us, urging us to push the boundaries of our knowledge and explore the unknown.